Moving on to the statements and state extension of this challenge. Right now, all we have is a glorified calculator, a glorified algebraic calculator, not even a scientific calculator, a simple algebraic calculator. Our programming language does not support statements. What are statements? This right here is a print statement. It's a command to the computer to print something, and then it terminates the state, and then we terminate the statement with a semicolon. So that's what a statement looks like. So anything followed by a semicolon is a statement. All right. And this particular one is a print statement. And if we were to have an algebraic expression followed by a semicolon, this would be an algebraic statement that our programming language might process. All right. So there are different kinds of statements. So the one in front of you right now is a print statement. After that, we're going to have expression statements. All right. So expression statements are just like I told you, anything other than the print statement is an expression statement. So we need a way to differentiate between these kinds of statements. And we'll do that by adding it to our context-free grammar. So this is what our context-free grammar looks right now. All right. But I'm going to make some changes to it. So this is what we had earlier. Now I'm going to add statements to it. So any program that you write is just going to be a list of statements. Any Java code or a JavaScript code you write is just a list of statements, one after the other, another. So what we'll do is, let's say that our program is just Control C, multiple statements, and then it's followed by an EOF, and EOF comes from end of file. So this is our program, and let's say our statement is of two types, a print statement and an expression statement. Print stmt and then an expression statement. We need to do this because print statement is a special kind of statement, and we need to be able to differentiate it from other, because print is built into our language. The print command, the print statement is a language built in that we are providing in locks. All right, that's why we need to differentiate it from other statements. So print statement is just the print keyword followed by, now it can be followed by an expression, and if it's followed by an expression, our programming language will evaluate that expression and then print it. But necessarily a statement must be followed by a semicolon. And similarly, an expression statement is just an expression followed by a semicolon. Let me increase the font size. So this is what we have. Our program is just a list of statements, and a statement can be of two types, a print statement and expression statement. A print statement is just the print keyword followed by an expression, which our programming language will evaluate, our interpreter will evaluate and then print. And an expression statement is just an expression followed by a semicolon. That's the change I'm going to make to my programming language. That's all the change that we need to make to our context-free grammar, but we need to add equivalent notes to our AST for it to make sense. So let us just read what they are asking of us. In this stage, we'll add support for the run command and handle running the print statement. All right. So right now in our main class, we do not have the run command. So let me add it. And in case if it's run, I'll call runner.run method. This is what I'll call. And since this method does not exist, let me create it. Method runner. Okay. So in here, the code is going to be quite similar to the previous one. Let me just copy it and make the required changes. So we'll read the file contents, we'll check if it's null, then we'll return, we'll scan all the tokens, we will parse through it. But then, as I told you, our program is just a list of statements. So instead of calling our interpreter on the expression, I want to run through. So this parse method right now returns only an expression. I want a parse method that can return a list of statements. List of. So we do not have that right now. Let me first then add the nodes of our AST first. So what we need to do is we need to come here in our AST, and right here we need to create a package called statements, and in the statements I'll create a Java class called statement.java. Now the statement.java is inspired from the expression.java class. Let me copy this, Control C, go back to statement, paste it here, and let me make it abstract. And instead of the expression visitor, we'll be using a statement visitor. It doesn't exist right now, so let me create that as well. So I'll create the statement visitor where we have the expression visitor, and it's an interface. So in the statement visitor, what are the types of statements that we are going to add to our programming language? Right now there are only two, a print statement and expression statement. So I'll add two methods for those. Let's go back and let's call them, let's make it generic. Let's call it visit print statement, and I'll call this one expression state visit expression statement. What we're doing is we are implementing the visitor pattern for the statements as well. Just like we had implemented the visitor pattern for expressions, we are implementing it for statements. So in the visit print statement, we're going to visit the print statement, and in the expression statement, we're going to visit the expression statement. Right now, these classes don't exist. I'm going to create them right now. So now I need to create a print class and a expression statement. Let me check the spelling, and expression statement class. So in the print statement, it's going to extend the statement class and implement the methods. So looking at our context-free grammar, a print statement is just a keyword followed by an expression. So in our print class, we need to have, extends statement, and let's import this. Let's import this. What's the issue? It is already implemented. What the hell is the issue? I'm not sure what the issue is. Public class print extends statement. Let me check the statement class. Oh, stupid. So like I told you, in our context-free grammar, a print statement is just a keyword followed by an expression. So in our print class, our AST node needs to store an expression in itself. So let me copy that what I mean. Uh, Add a public final expression and create a constructor with that expression. And similarly, our expression statement is also just an expression. So import the class expression, and that's it. So our expression statements and print statements are good. Uh, hmm. In the statement visitor, let me import these, and our express statement visitor is fine as well. Our statement class is fine as well. Our statement visitor is fine. Our statement is fine. Okay. And so this statements are going to be processed by our interpreter as well. So I'm going to write here implement statement visitor. Statement visitor, and the generic in it will be object. And let me implement the methods. So like I told you, a print statement is just an expression. So what we can do is we can simply expr.expression.accept this, and we'll return whatever was returned here. And since it's a print statement, we can print it right here, or we can print it. I'll print it right here. Instead, object result. Since it's a print statement, we should be printing it out. That's what I mean to say. And I'll just return it as well. Might as well return it. Right here, we need to print it. But we don't know what the result is. If it's a null, we can't print a null. We need to print nil, nil. And if it's an instance of double, then do you remember we did this? We removed, if our double, the decimal in our double was just 0, then we removed then we truncated the decimal. We need to do that here as well. So what I'll do is I'll create a method stringify, and I'll pass in the result right here. I'll create this helper method, and in this helper method I'll check it's going to return a string, and in here I'll check if the result is null, I should be returning nil, and if the result is an instance of double, by the way, you can do instance of small d in Java 25, I think, new features. If it's an instance of double, then I want to truncate it. So what I'll do is I'll just copy that logic. Let me copy it. Save. So I'll result, and instead of printing it, I will return plus val, and if not, I can return result dot toString. And if it was not an instance of double, I can simply return val dot toString. Oh, sorry, result dot toString. That will stringify it for us. That is the implementation of the print statement. Now coming back to the expression statement, an expression statement is not going to do anything. An expression statement is just an expression. It's not going to print. It doesn't have a side effect. The print statement has a side effect. Expression statement does not. It's just an expression that needs to be evaluated. So I'll call the accept method for the expression on it with this. Now the entry point of our interpreter class expects an expression. I want another entry point to our interpreter that can expect statements as well. So I'll call it state statement, and let's import it. So this interpret method is now is the entry point for all statements. All right. So the code is going to remain, the implementation is basically the same, just the entry point is going to change. All right. And we need a way to be able to parse those statements that we just created. We do not have that support in our parser yet. So right now we did this, and like I told you, we don't want to interpret. This is the run, right? We want to interpret, but we do not have that list of statement, and I want to be able to parse program. So I want this method to, I want to create this method in the runner parser class. Let's create it, and it's going to return a list of statements. Right now we have the list of statements, and in here, what I'll do is I'll just loop over them. Control X for statement S in E, and interpreter. I'll create a new interpreter right here, and object dot, and I will interpret the statement, and if result is, if we threw an interpreter exception, then we need to exit out with 70. Otherwise we don't need to print anything. We're not printing anything, so let's just remove this. We only need to execute the code in the run method, but we do not have an implementation of this parse program yet. This parse program is supposed to parse this newly created CFG, this CFG that has this program statement, print statement, expression statement as well. So in the parse program method, we know we are going to return a list of statements. So let me move it up near the entry point of this class parse right here, and let me copy this try catch, and instead of returning an expression, I want to create a list of statements, new array list, and we're going to parse the string content of the file until we are at the end, and we already have a method to check if we are at the end. While not at the end, I'll continue to parse. All right, I'll do a statements dot add, and I'll call the statement method, which we'll create shortly. It should be statement, and outside of the loop I'm just going to return statements. Now this statement method doesn't exist, and we need to create it. So in the statement method is just, it may be a print statement or an expression statement, so we need to differentiate, and we can differentiate it by matching on the keyword print. If the first token that we are parsing is a print keyword, then we know that what's going to follow is a print statement. So if we match current token to be print, in that case we know, sorry, not print, type, token type print, in that case we return a print statement, which doesn't exist right now, but we'll create. Otherwise we have an expression statement, and we'll return it. So we need to create these methods now, a print statement and an expression statement. Let me move the print statement above. So in the print statement, the control will come here only after matching the print token. And if you were to look at the implementation, the match current token already advances. So we have already moved ahead of the print. our pointer right now is pointing at the expression. Uh, since we matched the print keyword, our pointer is now at the expression. So what I can do is I can create an expression, and I'll call the expression method to help us do that, to parse the expression. And since our all our statements are followed by a semicolon, we need to consume a semicolon. If there is no semicolon, then we need to throw an error. We already have a method that does that for us. It is going to consume a semicolon type of token, and if it doesn't exist, we are throwing an error that they want us to actually. If you were to look at the instructions, uh, well, it's not here, but I think it's here. No, not here. Anyways, if you don't do this, you will see that they do actually want us to do this. So we expect a semicolon after value. So this is the error that they want us to throw, which we'll throw. And after that, I can just return a new print statement with the nested expression to be expression. And then, like I told you, an expression statement is just an expression. So again, we can do simply this. And instead of print, I will call the expression statement. With this, I think we're set. Let me go through the workflow. Control will come here, we'll go into the run method. In the run method, we'll read the contents of the file. We will tokenize all the content. We will go through the tokens and parse. We'll call the parse program method. And in the parse program method, we will loop until all the tokens are done, until we are at the end of the tokens. And until we are at the end, we'll keep on adding statements to our list, and then we'll return the list. Now these statements can be of two types: a print and an expression statement. It's a print if the current token is print, and it's an expression statement otherwise. The print and expression statements just have an expression in their body. So we parse an expression and create new objects of print and expression, and we return them. So after that, the control comes here. So if after parsing, the parser exception is equal to null, and the returned list of statements is not null, in that case, we create a new instance of interpreter right here, and we loop through those statements. So let me rename this to statements. We'll loop through those statements, and I'll call the interpret method on the individual statement. And if the result out of the interpret method is an interpreter exception, we exit out with a code 70. All right. Now we made this new method, interpret method. This interpret method is basically a copy of the original entry point of the interpreter. It's just expecting a statement instead of an expression. That's it. And it's just calling the accept method using the visitor pattern. That's the benefit of the visitor pattern. And that's all the changes we have done. We created a statement visitor, we created a statement, we created an expression statement, we created a print statement, and let me try to run it actually. I'll print hello world, and this will show me if there is an error. Let me see if the file is fine. Edit configuration. I may need to, yeah, this needs to be run, and okay, let's run it. Let's see the output. So it doesn't print anything. It didn't print anything. So let's go to the interpreter and wait, even for, let's go to the runner. And before coming here, let's check the list of statements that we created. Let us debug it. Continue. Continue. So in our list of statements, we have a single statement that's a print statement, expression, and the body is hello world. So let's go in here. We create we go into the interpreter. Let's step into it. Let's step into it. It calls the, oh, I didn't, yeah. See, right here, we need to call visitor dot visit print statement, and I'll send it this. Similarly, in our expression statement class, visitor dot visit expression statement, and I'll send it this. Now it should run. Yeah, it works. See? All right, so let's try to push our changes and see if it works. If it passes all the test cases, git add. So it passes all the test cases. You can see them running right now. It does, and you can go ahead. So since we already added a list of statements and we are already looping through them, we'll pass the next stage in this extension as well. So let's see. I'll get back to you when the tests are done running and you'll see them all passing. As you can see, all the test cases passed for multiple statements. And the next thing is expression statements, and you'll see the tests pass for it as well because we have already distinguished between the print and the expression statement. If you look at our CFG, where is the CFG? Our context-free grammar, we have already differentiated between the two, and we've already accounted for this. So it works, and finally we are moving towards something that looks more like a programming language. So the way you have a print statement, you can have multiple different kinds of statements, but our programming language only supports these two for now. You can add any of the other, like you can add a timer or something like that, anything you want. So I'll show you an example of that later on, but like you see print statement. Similarly, in C++, you would have a C in statement and then a C out statement, as they are a language built in. Similarly, a print statement is a language built in, and that's why we need to differentiate. So if our language supported C in and C out, so what I'll do is I will create another statement that will be a C in statement, and I'll show you how to add native statements to your language in another video. But that's it for this one, and I'll see you in the next one.